Because of the movement of the lithospheric plates, the rocks along the boundary of these plates are squeezed or stretched. For example, when two plates move toward each other, the rocks in between them are compressed. When two plates move away from each other, the rocks between them are pulled apart. When rocks in the lithosphere are squeezed or stretched, they store energy. When the rocks have been deformed beyond the limit, the rocks break and the stored energy is released. Now that you know the relationship between faults and earthquakes, it is time to get to know the meaning of terms used when earthquakes are reported in the news. So we have the epicenter and focus, magnitude, and intensity. The breaking of rocks will start at the point where the rocks are weakest. Earthquakes start at a point within the earth called focus. Focus or hypocenter is the origin or the center of the earthquake located underground. The released energy, called the seismic waves, travel through the ground outward in all directions. The focus or hypocenter, as have mentioned earlier, is the weakest part of the crust where the slippage of rock occurs. The area on the Earth's surface directly above the focus is called the epicenter. The most violent shaking of the ground is felt, and consequently, the greatest damage happens at the epicenter. Earthquakes continue until all the energy released at the focus has been safely dissipated. This explains why the earthquake that we experienced last December 25 of 2020, wherein the epicenter is in Calatagan, Batangas, the violent shaking was felt there in Calatagan, Batangas, and it explains why some of us here in Bulacan were not able to feel the shaking, probably because some are still sleeping because it happens 7:30 in the morning. There are two ways of describing an earthquake. It is by intensity and magnitude. Magnitude is the measure of energy released at the source of the earthquake. Magnitude is determined from measurements on seismographs. Seismographs produces papers with upper and lower lines called the seismograph. A seismograph or seismometer is an instrument used to detect and record earthquakes. Generally, it consists of a mass attached to a fixed base. During an earthquake, the base moves and the mass does not. The motion of the base with respect to the mass is commonly transformed into an electrical voltage. The higher the lines or the waves, meaning the greater the vibrations. The Richter scale is used to measure the magnitude of an earthquake. So here is an example of a Richter scale. As you can see, it is expressed using Hindu-Arabic numbers. It was developed by Charles Richter, a seismologist from California, USA. This scale determines the range of the largest seismic waves recorded in the seismogram and the distance to the epicenter of the earthquake. Remember that if a place is located near the epicenter of the earthquake, the location just above the focus, it will experience greater shaking. That is why it will have a higher magnitude.
While intensity of an earthquake is observed by the strength of how severe the shaking effect of the earthquake to the Earth's surface, to humans and structures present. So when we say intensity, we are referring to the effects and damage produced by the earthquake. It is determined by going to all the areas affected by the earthquake and observing the damage, as well as recording the experiences of the people there. Remember that if a place is located near the epicenter, it will experience greater shaking. That is why the magnitude is higher. Therefore, if the magnitude is higher, the intensity is also high. So we have here the Pivolts Earthquake Intensity Scale, or the PEIS. The Earthquake Intensity Scale starts with Roman numeral number 1, which is described as scarcely perceptible, and the highest is 10, which is completely devastating. So for intensity 1, it is perceptible to people under favorable circumstances. Delicately balanced objects are disturbed slightly. Still water in containers oscillates slowly. For intensity 2, slightly felt by few individuals at rest indoors. Hanging objects swing slightly. Still water in containers oscillates noticeably. For intensity 3, weak, felt by many people indoors, especially in upper floors of buildings. Vibration is felt like one passing of a light truck. Dizziness and nausea are experienced by some people. Hanging objects swing moderately. Still water in containers oscillates moderately. Intensity 4, moderately strong, felt generally by people indoors and by some people outdoors. Light sleepers are awakened. Vibration is felt like a passing of heavy truck. When you felt that as if there is a heavy truck passing, but there is not, probably there is an intensity 4 earthquake. Hanging objects swing considerably. Dinner plates, glasses, windows, and doors rattle. Floors and walls of wood-framed buildings creak. Standing motor cars may rock slightly. Liquids in containers are slightly disturbed. Water in containers oscillates strongly. Rumbling sound may sometimes be heard. Intensity 5, classified as strong. Here is the description. Generally felt by most people indoors and outdoors. Many sleeping people are awakened. Some are frightened. Some run outdoors. Strong shaking and rocking felt throughout building. Hanging objects swing violently. Dining utensils clatter and clink. Some are broken. Small, light, and unstable objects may fall or overturn. Liquids spill from filled open containers. Standing vehicles rock noticeably. Shaking of leaves and twigs of trees are noticeable. Intensity 6, classified as very strong. Many people are frightened. Many run outdoors. Some people lose their balance. Motorists felt like driving in flat tires. Heavy objects or furniture move or may be shifted. Small church bells may ring. Wall plaster may crack. Very old or poorly built houses and man-made structures are slightly damaged, though well-built structures are not affected. Limited rockfalls and rolling boulders occur in hilly to mountainous areas, and escarpments. Trees are noticeably shaken. Intensity 7, destructive. Most people are frightened and run outdoors. People find it difficult to stand in upper floors. Heavy objects and furniture overturn or topple. Big church bells may ring. Old or poorly built structures suffer considerable or considerable damage. Some well-built structures are slightly damaged. Some cracks may appear on dikes, fish ponds, road surface, or concrete hollow block walls. Limited liquefaction, lateral spreading, and landslides are observed. Trees are shaken strongly. Liquefaction is a process by which loose saturated sand loses strength during an earthquake and behave like liquid. Intensity 8. Very destructive. People are panicky. People find it difficult to stand even outdoors. Many well-built buildings are considerably damaged. Concrete dikes and foundation of bridges are destroyed by ground settling or toppling. Railway tracks are bent or broken. Some stones may be displaced, twisted, or overturned. Utility posts, towers, and monuments may tilt or topple. Water and sewer pipes may be bent, twisted, or broken. Liquefaction and lateral spreading cause man-made structure to sink, tilt, or topple. Numerous landslides and rockfalls occur in mountainous and hilly areas. Boulders are thrown out from their positions, particularly near the epicenter. Fissures and fault rupture may be observed. Trees are violently shaken. Water splash or slop over dikes or banks of rivers. Intensity 9. Devastating. People are forcibly thrown to ground. Many cry and shake with fear. Most buildings are totally damaged. Bridges and elevated concrete structures are toppled or destroyed. Numerous utility posts, towers, and monuments are tilted, toppled, or broken. Water sewer pipes are bent, twisted, or broken. Landslides and liquefaction with lateral spreadings and sand boils are widespread. The ground is distorted into undulations. Trees are shaken very violently with some toppled or broken. Boulders are commonly thrown out. River water splashes violently or slops over dikes and banks. And finally, intensity 10, completely devastating. Practically all man-made structures are destroyed. Massive landslides and liquefaction, large-scale subsidence and uplift of landforms, and many ground fissures are observed. Changes in river courses and destructive sitches in large lakes occur. Many trees are toppled, broken, and uprooted. This is written again in Roman numerals and assessed in modified Mercalli intensity scale, which was developed by Giuseppe Mercalli in 1902 and used to measure the intensity of an earthquake through its shaking effect. So again, intensity of an earthquake is determined by observing the effects of earthquake in different places. Houses, buildings, and other structures are inspected. People are interviewed about what they saw, how they felt, or what they did. Now let us compare. When we say magnitude, it is the energy released by an earthquake at the focus. It is calculated from earthquakes recorded by an instrument called seismograph. We have the Richter scale using Hindu-Arabic, whereas for intensity, it is the strength of an earthquake perceived and felt by people in a certain locality. Intensity is generally higher near the epicenter. It uses Roman numerals. Now, as mentioned during the discussion about earthquakes and faults, Philippines is one of the countries included in the Ring of Fire, where the chain of active volcanoes and seismic activity sites encircles the Pacific Ocean. The movement from the ocean trenches, volcanic eruptions, and epicenters of the earthquake happens along the boundaries of tectonic plates called fault lines and have evidence of seismic activity. It's important for us to understand if the place where we live, or if you're planning to buy a property, if your place is located along an active fault. Now, what is an active fault? An active fault is a fault that is likely to become the source of another earthquake sometime in the future. Geologists commonly consider faults to be active if there has been movement observed or evidence of seismic activity during the last 10,000 years. Imagine. Inactive faults are the structures which do not show or experience any earthquake and any seismic activities in the last 10,000 years, but they may still generate any seismic activity like earthquake in the future. So here are the fault lines in the Philippines. We have the Central Philippine Fault, Marikina Valley Fault, now called as the West Valley Fault System, the Western Philippine Fault, Eastern Philippine Fault, Southern of Mindanao Fault. So of the fault system in the Philippines, the one that the seismologists or geologists have been monitoring for the past years, and the reason why we are constantly doing the earthquake drills, is the West Valley Fault System. The West Valley Fault is 100 kilometers in length and traverses the cities of Metro Manila, namely Taguig, Muntinlupa, Parañaque, Quezon City, Pasig, Makati, and Marikina, as well as nearby provinces of Rizal, Laguna, Cavite, and Bulacan. These places will suffer greatly when this fault moves. According to PIVOX, Marikina Fault Line, or the West Valley Fault, is the most geologically active fault line in the Philippines. It has been estimated that it has not moved to produce high-intensity earthquakes for at least 400 years. The West Valley Fault System is located east of Metro Manila and cuts through all modern and progressive portions of Manila, Rizal, Marikina City, Quezon City, such as Eastwood, Rockwell, Ortigas Center, Bonifacio Global City, Ayala Center, and Alabang. It is about 1 kilometer away from Pasig City, Laguna de Bay, and leading to Taal Volcano. Initially, it was called Marikina Valley Fault, and it was renamed to West Valley Fault during the term of PIVOX Director Raimundo Punumbayan, because it caused a panic to the residents of Marikina as well as the most of the businesses community within the inclusive areas. Seismologists said that once the West Valley Fault line moved, it can lead to the eruption of Taal Volcano. This is what happened in June 1990 earthquake when the Central Philippine Fault moved. Mount Pinatubo, which had not erupted for about 600 years, erupted July 1991 of the following year. Remember that Taal Volcano erupted January of 2020. Now at this point, let us check your understanding about the terminologies which has something to do with earthquake. Number 1. What do we use in reading the earthquake's intensity? A. Kilometers, B. Roman numerals, C. In Hindu-Arabic, D. Miles. Alright, the answer is Roman numerals. For magnitude, we use Hindu-Arabic. Number 2. According to PIVOX, a geologically active fault line in the Philippines is located east of Metro Manila, has not moved for almost 400 years. Seismologists say that once it moved, it can lead to the eruption of Taal Volcano. Which fault line is this? A. Central Philippine Fault, B. Western Philippine Fault, C. West Valley Fault, D. Eastern Philippine Fault. Alright, Alright, for number 2, the answer is the West Valley Fault. Number 3, the 1990 Luzon earthquake struck the Philippines at 4:26 p.m. on July 16 with an estimated moment magnitude of 7.7 and Mercalli intensity of 9, considered as violent, and produced a 125-kilometer long ground rupture. Which of the following statements is true about intensity and magnitude? A. Intensity is the measure of energy released by the earthquake, while magnitude is the damage produced by the earthquake. B. Magnitude is the measure of energy released by the earthquake, while intensity is the damage produced by the earthquake. C. Magnitude is determined by going to all areas affected by earthquake, while intensity is determined by using seismographs. D. Intensity is calculated from the height of the largest wave, while magnitude depends on recorded experiences of people living in the area. Okay, I'll give you 15 seconds. Take your time, analyze the questions and the choices carefully. Read the questions carefully and analyze the choices. Ten seconds. Okay, time's up. For number 3, the answer is letter B. Remember that magnitude is the measure of energy released by the earthquake, while the intensity is the damage produced by the earthquake. Number 4, a magnitude 6.3 earthquake occurred in southern Batangas province at 7:43 a.m. on December 25, 2020. The epicenter was about 5 kilometers or 3 miles southeast of Calatagan, Batangas. Where would shaking be greater? A. Near the epicenter. B. Away from the epicenter. C. Near the focus. D. Away from the focus. Alright, the answer is letter A. Of course, it is near the epicenter. Number 5. Point A, this one, where slip initiated during the earthquake is called A. Dip, B. Focus, C. Epicenter, D. Fault. Okay, for number 5, the answer is, okay, letter B, focus. Thank you for watching this video lesson. See you again next time for